cutoff cycle is a little different than the grooving cycle. We actually have a block that can be inserted in the program specifically for cutoff. Of course, you could program just a simple groove that comes all the way to X0 or past 0 to cut the part off, and that would be fine. But if you want to take advantage of using the parts catcher, for example, if you have a parts catcher, then and some of the other control things that we're going to have here for the advanced pecking and so forth, then we're going to want to use this actual block. As we've seen in the grooving cycle and threading cycle, we can check box the use safe rapid point. This gives you the ability to program a location where this tool is going to rapid to both at the beginning and the end of the grooving or the cutoff cycle, which will mean that you don't have to use a position block as we've had to do in older versions of software. I'm going to put the X diameter start, the Z start, which is the location where we're going to program. And notice in the very bottom right corner we have width compensation, yes or no. That determines, based on the little graphic, should concur with whatever it is you're trying to do, whether you're programming to the front or back side of the insert with that Z start. So we do have width compensation on the cutoff cycle, which we did not have on the grooving cycle. You always program to the back side of that particular tool. If you have a parts catcher available on your machine, then you can advance the parts catcher by answering yes here. Then it gives you the ability to put the diameter at which time you want the parts catcher to advance. This would mean if I'm cutting off a very large 3-inch part, for example, I don't want the parts catcher to advance at 3 inches because I'm going to cut all of that material. All the chips are just going to fall on my parts catcher and I'm going to catch 3 inches worth of material. So I want to wait and advance the parts catcher more at a more opportune diameter, maybe 1/4 inch, something like that. That way I'm going to limit the amount of chips that I'm going to pick up with the parts catcher. Pause at the end. I can put a second value in there, or a value in seconds, that how long do you want the tool to stay in case you're running let's say you're cutting rings off of a piece of tubing and it's a very large diameter. You want to pause once you get to that diameter to allow the full revolution of the chuck, so you are actually separating the entire part. And then we have the X end diameter, or where it is that the tool is going to go for its final diameter. Notice that the tool orientation over on the right-hand screen there, or the right side of the screen under tool offsets, you see the orientation again, just like the grooving tool. You can actually use a grooving tool if you choose to, but it's going to have the orientation the same as a turning tool, front left corner or upper left corner for an ID type tool. The advanced pecking. Many times when you're cutting off a part, the closer you get to the center of the spindle with constant surface speed, the faster it begins to spin the chuck. And when you finally do separate that part, it's going to fling the part at somewhere in the machine. It might hit the windshield, whatever. The advanced pecking gives me the ability to check box 1, 2, or 3, and at different RPM or different diameter settings, I can then both reduce my speed and my feed rate. So that should help from keep the part from flinging as I get closer to the center of the tool. I can slow that down. Something else I don't have available in a grooving cycle. Now here's the cutoff. The cutoff the tool setup for a cutoff tool is really no different than the grooving tool itself. The only difference is I'm calling this a cutoff tool. That way when I'm looking through my tool list, it may be easier for me or my operator to determine what is a cutoff tool and what is just simply a grooving tool.